Welcome to the Math 1 lesson summary video for the task Features of Functions. This is a practice understanding task, and you can see the purpose is to practice interpreting key features of functions from a graph, table, or situation. So we'll make sure that we do one of each type of problem, a graph, a table, and a situation, meaning a real-world situation. So as you can see, for the graph section, the instructions are, for each graph, determine if the relationship represents a function, and if so, state the key features of the function, and it lists the key features that we want to consider. So let's look at graph 3. First of all, it is a function, and to see if something is a function from a graph, you may have heard of something called the vertical line test. So what the vertical line test does is it says for every x, so I draw a vertical line through the x value, it should only be one y. And so as long as all these vertical lines that I draw only hit the graph in one place, then it is a function, and I could draw the vertical lines anywhere. It should only hit it one time for it to be a function. So you can see that this is a function, so we can now proceed with analyzing it and interpreting its features. Remembering that domain is the set of x values of the function, we want to look at the furthest left that the graph goes, which is here at -8. And then the furthest right that the graph goes, which is here at 10. Notice I'm using the square brackets because the values -8 and 10 are included in the graph, and we can tell that because these are closed dots here on the endpoints. Now for the range, we want to consider the lowest point on the graph. So our lowest point is down here. That's at a y value of -3. Again, square bracket because it's included. And then our highest value is up here, and that's at a y value of 5. Now, it just so happened that the lowest and highest points were also occurred at the same points as the furthest left and the furthest right, but it doesn't always have to be that way. For example, if this graph had had a little steeper peak in here, then it would have changed our range. So just want to mention that. Next up, we want to consider intervals of increasing and decreasing. So remember, to do that, I like to think of a little person riding the graph like a roller coaster. So for this first section of graph, I'm going to do increasing in green here. This person is going up, going up, going up, going up, going up, going up, going up until we get to here. So the function is increasing from -8 all the way to 0. So remember, increasing, we're listing the x values of that interval on which the y values are increasing. So we're looking at the y values to figure out where it's increasing, but what we write in our interval is the x values. And then later on, we're going to have this other section of increase. So it's starting down here. It's increasing again for the final part of the graph. So I could describe that interval as being from 5.5 to 10. Again, talking about the x values. That means there's an interval of decreasing in between the two intervals of increasing, as we can see there on the graph, which would be from 0 to 5.5. So notice how those correspond with the end of the first increasing interval and the beginning of the second increasing interval. So everything on the domain is covered. So let's talk about maximums and minimums. So we already mentioned from the beginning when we did the range that the global maximum occurs here at the highest y value of the graph, and so that was 5. And the global min occurs over here at the lowest point of the graph. And so that was -3 was the y value. So if I just say maximum or minimum without writing anything in front of it, it's assumed that I'm talking about global max and global min. But there are also these other points. So we have this point here, which is a relative max. And so this point looks like 0, 4.2. It's also the y-intercept of the graph. So relative max occurs when there's a change from increasing to decreasing, and then when there's a change from decreasing to increasing, we get something called a relative minimum. And so this would be something like 5.5, 0.9. And also let's mention that we have an x-intercept over here. And so the coordinates of that x-intercept look like maybe negative 6.2, 0. Now for this graph, there's not going to be any symmetries, and we're not going to discuss the end behavior because we usually only talk about end behavior when the graph is extended based on arrows on the ends of the graph. But when it stops at points, as it does here, we don't talk about end behavior. So that's it for problem 3. Let's take a quick look at problem 5. It is not a function because we have this one x value going to two y values, so it fails the vertical line test. So we can say it is not a function due to x equals -9 going to multiple y values. And again, that can't happen with a function, so it's not a function. Next up, we want to analyze from a table. So number 8, it says the table on the right represents a continuous function defined on the interval from 0 to 6. So because it's described as a continuous function, that means we can determine the domain based on the statement that they already gave us, which is that x is from 0 to 6. So to figure out the range, we need to figure out the lowest y value that's achieved and the highest y value that's achieved. So the lowest y value I see is -3, and the highest I see is 20. So that means that the range is going to be from -3 to 20. X-intercepts would be places where the y value or the function value is 0. So this is our x-intercept right here. So that's 2, 0. That's a point, not an interval. And then our y-intercepts occur when the x value is 0. So that's 0, 2 is our y-intercept. And it says, based on the table, identify the minimum value and where it is located. So we've already talked about from the range, the minimum value is y equals -3, which occurs when x equals 1. Now, I just want to mention in problem 9 a little subtle difference. So it says this is a discrete function, meaning these points are the only points on the graph of the function. It wouldn't be connected like it would be in problem 8. So because of that, when we write domain and range for a problem like number 9, we just list the values. So I list all the x values, 1, 2, 3, 4, 5, because the points in between those are not part of the domain since it's discrete. And for the range, I just list the y values, and I like to try to list them in ascending order. So we have 3, 4, 5, 8, 10. So notice the difference between how the domain is written in a continuous situation as an interval versus in a discrete situation in problem 9, where it's just a list of numbers as a set. And that's causing me to notice one mistake I made, or not mistake, but omission. In problem 8, there should be another x-intercept because it's continuous. So we had the one x-intercept when it went from negative to positive, but it also went from positive to negative y values. And for that to occur, there had to be an x-intercept somewhere in there. So we don't know for sure, but we could approximate it as maybe 0.5, 0 as our range. And so I just wanted to point that out. So finally, we wanted to look at a situation. So number 12 is a situation. Marcus bought a couch for $900 on 6 months interest-free payment plan. He makes $50 payments to the loan each week. So let's actually start with the range for this scenario, because that's the most easy to think about from the information given. So he's got his $900 couch. He's paying off $50 each week. So 900 down to 850, down to 800, down to 750, and on and on and on until he gets to 0 and he's paid off the couch. So using our knowledge from the first module about arithmetic sequences, which is what this is, we can figure out that it would take 18 weeks for him to pay off this loan, because they're asking us to break it down in terms of weeks on the domain. So he's going to be paying it off from 0 weeks to 18 weeks. And that's a continuous interval because time is continuously changing. So this is a scenario where it's decreasing. So the interval of decreasing is the same as the interval of the domain, because it's decreasing the entire time. There's no increasing. Our maximum value and our y-intercept are the same in this scenario, because we have at 0 weeks he owed $900 on the couch. So that's the highest value, and it's also the y-intercept, the starting value. And then the minimum and the x-intercept are the same, which is going to occur at 18, 0. So we've now looked at a situation, tables, and graphs, and interpreting the key features of functions in those places. Hope this video was helpful. If you need help with the Ready, Set, Go homework problems, then check out the Ready, Set, Go homework support videos and the student support site in Canvas.